Thanks for waiting. Sorry for the slight technical difficulties. My name is Gavin, and I've come here today to talk to you a little bit about some of the things that I've been working on, but most importantly, the reasons for this work. And I'll try to express these reasons in as sort of abstract, general, and neutral a way as possible. And hopefully, they'll be a little bit insightful. So, the broad push of the talk is to explore what Web3 means beyond the context of strict technical protocols. So before we can sort of do this, we have to explore what Web3 is. So what is Web3? Web3 is obviously not NFTs, although I think there has been some confusion in the past. It's also not merely blockchain. A perhaps more thought-through answer might be that it's decentralization and crypto economics. And this gets, this gets close, but in fact these are the means by which we can implement things in a Web3 manner. In fact, I'm gonna argue, I'm gonna stand here and say, no, it's none of this is really what Web3 is strictly about. Although in some sense, Web3 encompasses all of them. I'm going to say, well, actually, Web3 is about building resilient digital systems, resilient digital services. Now, by resilient, we might mean, unstoppable or live, if we're going to be, more academic about it. Might mean incorruptible or correct, if we're going to be more academic about it. And actually, there's a few other properties that it turns out are quite nice to have in Web3 digital services. Generality, which might reasonably be considered the sort of difference that Ethereum made when it sort of came along to a blockchain world that was dominated by Bitcoin. Scale and performance. Coherency, which is essentially how easy it is for disparate parts of the system to interact. And accessibility, how easy it is to use the system. But first and foremost amongst these is resilience. If it's not resilient, then it can't, I say, it cannot truly be considered Web3, and it can only be considered Web3 to the degree that it is resilient. Okay, so I think I would hope it's reasonably easy to see why these properties can be applied to digital systems, particularly the protocols that define them to a large extent. And indeed, protocols are generally judged on how well they adhere to these principles alone. And this is kind of okay, but it sort of implies that a protocol should be considered alone, kind of like a snapshot in time. It's like if we snapshot this protocol as it is right now, how resilient is it? How scalable is it? How general is it? But the reality is that protocols are not snapshots in time. Protocols rely on an ability to change within their environment, just like everything else that lives in the real world. And as such, they rely on those humans that manifest this change. If you compromise on your ability to engage those who maintain, adapt, understand, reinvent the protocol, then the protocol itself is composed. Maybe not the snapshot of the protocol at one point in time, but the protocol and the service that it offers can become compromised. Now, you might not notice this, especially in a sort of large, vibrant ecosystem. And I think this is in part because there's a lot of altruism, or there can be a lot of altruism and a degree of shared identity, nationhood, kind of digital nationhood, if you like. And this can mask the existence of a problem. And I kind of liken this a bit to how the free software ideology, in some sense, masked the fact that it costs money to develop open source software. But the costs of development are real. They have opportunity costs, which are extremely real. And if you look at open source software in certain areas, in particular blockchain and AI, those costs are very large. And we do not see the kind of free software ideology moving at nearly the same pace into these areas. I would say that the same is probably true in Web3. Opportunity costs abound. So we need to manage the fact that these costs exist. Now, protocols, as I kind of mentioned earlier, protocols rely on a foundation of people. Now, by a foundation, I don't mean a Stiftung foundation, right? I don't mean a legal organization. I mean, like, literally, the foundations. The foundation of a protocol are the humans that understand the protocol well enough to bring it forward, to help it adapt in the real world. And just as a Web3 protocol treats humans in some sense as utilities or as commodities to be utilized for example, securing the network, invalidating or mining, it's not unreasonable for a Web3 protocol to treat another set of humans in another manner, as a utility of another type, specifically those who allow it to adapt, develop, maintain itself. The coders, the engineers, the designers. Now, we will typically think, because we're in the early days of this industry, we can typically imagine that, well, actually, the protocol follows the humans. The protocol doesn't use the humans. In some sense, the humans use the protocol, right? Like, they create a protocol because, I don't know, they're doing their own bidding. They're not doing the protocol's bidding. But as time goes on, assuming we're not just going to constantly reinvent protocols, constantly create new protocols and old ones die, then we will have to alter, protocols will have to alter to a mechanism whereby a model, whereby they utilize this underlying talent, not the other way around. So yeah, a digital service can be viewed as an agent of this broader human environment, and it encompasses all sorts of tides and eddies, social, economic, legal, and physical in their nature. And this environment is constantly changing. Pretending it's not is obviously quite silly. And as an agent within this environment, a Web3 protocol really has to accept that it may need to change or adapt as its environment changes. On a very concrete, practical level, bugs may be found in the protocol that need managing. This would compromise resilience if they're unable to be managed. New tech or maths might appear, be discovered, and this could compromise generality of performance, especially in relation to other competitor protocols. Accessibility or even coherency could be compromised as a result of novel environmental adversities. As an example, I draw upon, it's easy to point to something, for example, in the Ethereum ecosystem. I mean, Ethereum's gone through, I don't know, umpteen protocol upgrades, right? Each attempting to adapt to a changing environment, whether the changes were academic, newer cryptography, whether the changes were based on the knowledge, the improved knowledge of underlying developers, for example, that one cryptographic function will actually outpace another one and therefore should be introduced into the protocol. Or other better understandings, for example, managing things like scaling and so forth. In short, Web3 protocols rely on humans for all sorts of things: direction, design, implementation, deployment, maintenance, and transition, and arguably representation. It could be that the protocol itself somehow needs to represent itself in the real world. It has to, like, you know, at times it can make sense for a protocol to issue a dictate, to say this is what this protocol thinks, or to represent itself politically speaking. We have to also manage the fact that people tend not to agree. Sometimes they do agree, and that's great, but when they don't, it can be a problem, but it can also be an important element of human discovery. The mechanism of change of a protocol is a combination of a broad agreement over the change and capable enough engineers, humans, designers, that can enact this change. And the two are linked, but they don't necessarily flow from each other. So let's think of like some of the kinds of technical governance in the real world. Some protocols just coded by, a guy in a bedroom, like tapping away, released. I mean, this in terms of this kind of strong Web3, this is not much better than Bob chain, right? Where it's just a guy who's actually running the chain. Yeah, there's a bus factor of 1. You can also see in some other, like a particularly well-known blockchain, governance by merge rights, right? So it's like if you control this particular repo, then you control the protocol. I don't think this particularly stands to scrutiny either, for obvious reasons. There may be a way of creating a bus factor of more than 1 over implementers, for example, by having multiple implementation teams. But a protocol may be heavily dependent upon a benevolent dictator who helps determine the direction of the protocol itself rather than the design decisions that any particular implementation makes. And another example would be like a single development team that's backed by some central entity, a foundation or a company. Now we see each of these in the real world. None of them feel particularly strongly Web3. None of them feel particularly in line with those Web3 ideals that I introduced earlier, not least resilience. Now, base layer protocols, I think it's probably not especially controversial to say that these ought to be largely unopinionated. The more opinionated they are, the kind of less likely they are to sort of stand the test of time and to appeal on a broad and general in a broad and general way. Unfortunately, despite or attempting to make protocols unopinionated, all practical systems ultimately harbor opinion. They harbor trade-offs. And to some degree, they belie particular policy. You might choose to implement one feature that is perhaps, let's say, more gray area than some other features. But perhaps it's more useful as well. These represent trade-offs, and usually perfect, objective, and constant answers don't lie at the root of all possible protocol change questions. Sometimes people hold legitimately different opinions. Sometimes not enough information exists to make a particular answer in the fullness of time. But maybe a decision is needed. Now, the way that we do this is, broadly speaking, governance. Governance manages decision-making in an imperfect world. Now, protocol engineers can be an important source of information for a protocol when it wants to make these decisions. But they can't be trusted with the keys to the farm. Particularly on matters of product and policy, which tend to be the more opinionated side of things. Protocol engineers may feel that they know the answers to these questions, but in reality, they probably don't. At least not all of the time. We can't generally rely on them, in part because, hey, they may not agree, and there may not be a clear decision that they can make. There are a few of them, which compromises accessibility a lot of the time, and we must remember that although perhaps once it may have been asserted, code writing is not protected from environmental adversaries. Just ask the developers of one particular fairly famous Ethereum smart contract. This would compromise the protocol's resilience. They also lack legitimacy for making policy decisions and even product decisions that affect a huge stakeholder community. Now, unfortunately, for a protocol, its engineers are not exactly commodities. Indeed, engineers really pose a strategic risk for the protocol. Now, you have the protocol engineers who are a long-term risk. If they walk away, the protocol is probably not going to be a particularly, it's not going to die immediately, but it may not be able to evolve as fast. It may need to recruit others. Software engineers, on the other hand, implementation teams, tend to be crucial to a protocol's day-to-day. Right? If there's a bug, then you need the software engineers around to fix the bug. And these guys generally have to have a very good understanding of the protocol as well. Now, we have to also understand that a core development team is can be an Achilles heel for a protocol. Compromise the development team, you compromise the protocol. And we've seen a few examples of this in the past. I don't think you have to look too far. So what makes a protocol strongly Web3? Redundancy, decentralization, and diversity, much the same as the regular way of making a protocol Web3. No invisible hand organizations or individuals, right, controlling the protocol, and no privileged organizations or individuals. Pretty basic stuff. So let's dive a little deeper into it. How do we engineer a protocol to be strongly Web3? Well, firstly, a strong protocol definition. There's been some talk of strong versus weak protocols. Well, I'm going to argue that weak protocols are dumb and strong protocols are where it's at. A strong protocol implies equidistance from all implementer teams, minimal bias towards non-protocol concerns, in particular implementation concerns. And in order to help do this, formal notation, which is not specific to any particular language or implementation, doesn't concentrate on the how, only on the what, is a very helpful tool. A very clear, transparent, and advantageous means of working out what changes should be made to the protocol and deciding on them. Now, the RFC process can be helpful, but it's not enough. It relies to some degree on sensible governance, meritocracy, clear rules, and no persistent privilege. And of course, finally, there have to be some incentives to ensure that there is resilience and redundancy and diversity within implementations, both within the actual software. Part of this could be helped by, for example, incentivizing different languages, and also in the teams, incentivizing different teams rather than just one team that makes multiple implementations. To do this, well, it really helps to have a strong protocol definition, and then there's also, material means and incentives. Finally, as a sort of, practice what you preach, This is what we're trying to do in order to do this, in order to have a strong Web3 protocol. Fellowship, on-chain governance, USDT salaries at OECD levels, right? Sensible salaries given out for its protocol experts. Transparent protocol ownership. Who gets to make the decisions? Well, that should be transparent. How do we we use on-chain mechanisms in order to actually enact these protocol decisions, or rather the decision-making apparatus at least. Having a manifesto within the governance which sets out the expectations for rank. Introducing long-term incentives for teams to get involved, and trying to incentivize, as I say, redundant teams, so that if 1, 2, 3 teams drop out, it's not a big deal. Diverse languages, so if there's some systematic design flaws that creep in on one language set, it doesn't spread to the others. Hardware support. And then finally, things like travel support and auditing support, right? All of the things, all of the big pain points that prevent teams from fulfilling their ability to nurture, to cradle the protocol. Good. I'm going to skip that last slide because I'm over time. Thank you for your attention.